Good morning, students. Now coming to mutations and genetic code. Mutations and genetic code. You know the properties of genetic code in a previous class. Code is triplet, code is degenerate, code is unambiguous and specific, code is commaless, code is nearly universal, starting codons and ending codons, and all of them they are the properties of genetic code. Now coming to mutations and genetic code. Students, the relation between DNA and the genes can be studied in mutation studies. They are best understood in mutation studies. So, relation between DNA and the genes. Relation between DNA and the genes can be understood by mutation studies. Very important. Mutation studies. Okay, can be understood by mutation studies. You know, deletions and rearrangements in DNA. Okay, one is deletions. Okay, what is deletion? Deletion means a part of the genes, a part of DNA is broken and lost. A part of the sequence of DNA is broken and the lost. That is considered as deletion. And rearrangements. Rearrangements means changes. So deletions and rearrangements, they lead to mutations in DNA. They lead to some changes in the genes of DNA. Okay, and these type of deletions and rearrangements, they lead to mutations. Lead to mutations, changes in the sequence of base sequence of DNA. Deletions and rearrangements, they lead to a change, alteration or the change in the base sequence of DNA. Okay, ultimately they leads to mutations, and these deletions and rearrangements, they lead to either loss or gain, loss or gain. So deletions lead to the loss of genes, rearrangements lead to the gain of genes. These deletions and rearrangements, they lead to loss or gain of the genes, and so the genes, the characters also, and so the characters. Okay, these type of changes and alterations in a base sequence of DNA, they are considered as mutations. Students, here a classical example. Okay, for example, a change, the mutation that takes place in DNA at the level of single base pair. A change that takes place at the level of single base pair in DNA, that is considered as gene mutation. This is called gene mutation, or this is also called point mutation. This is point mutation or gene mutation. What is point mutation and gene mutation? The change that takes place at the level of single base pair in DNA. This is the change in a single base pair of DNA. The mutation that takes place exclusively at the level of single base pair in DNA, that is considered as gene mutation, and this is also called point mutation. Okay, one of the best example for this gene mutation or point mutation, this is sickle cell anemia. Sickle cell anemia is one of the best example. Very, very important. What's the example for point mutation? Sickle cell anemia. Okay. Now coming to the classical example for this point mutation, that is sickle cell anemia. And how the sickle cell anemia is established in human beings? This sickle cell anemia, this is due to a change in the base pair. This is due to a change in the single base pair of the gene which is responsible for beta hemoglobin. Okay. So, point mutation, that is example sickle cell anemia. Sickle cell anemia is due to a change in the base pair of the gene responsible for beta globin chain. Beta globin chain. Okay, beta globin chain. That is the change in the single base pair of the gene responsible for beta globin chain, where the codon which recognizes the glutamic acid is changed into the codon that recognizes well. Okay, so one of the codon that recognizes glutamic acid, okay, due to a change in the single base pair of the codon that recognizes glutamic acid, it is converted into the codon that is recognized valine. Okay. So one of the codon which recognize the glutamic acid is changed into the codon that recognize valine due to a single base pair change, alteration. Because of this reason, glutamic acid it is replaced by valine. The codon which recognizes glutamic acid is changed into the codon that recognizes valine, so that valine is replaced at the place of glutamic acid. Ultimately, it leads to the disease condition. Such disease condition is called sickle cell anemia. So, sickle cell anemia is one of the example for point mutation. This sickle cell anemia is due to a change in the single base pair of the gene responsible for beta globin chain of human beings, where the codon that recognizes glutamic acid is changed into the codon that recognizes valine, so that valine is replaced at the place of glutamic acid. So it leads to a disease condition that is called sickle cell anemia. Now coming to another one, how it change, how the amino acids are changed in polypeptide chain due to a change in mutation, due to a change in codons. Single H due to change at the level of single base pair in a codon is converted into some other codons and also recognize some other amino acids, and it can be explained by this. There are UCAG, they are present in mRNA. These four bases are present in mRNA. For example, UGU. This is one of the codon. UGU is one of the codon. It recognizes amino acid cysteine. For example, this is one of the codon that recognizes amino acid cysteine. So, the first letter U, it may be changed. It may be replaced by some other and other nitrogen bases. Middle letter G may be replaced by these letters. Third letter U may be replaced by this. Okay? This, for example, when the third letter, when it is replaced by C, third letter when it is replaced by the C, it leads to the formation of the codon UGC. Okay? For example, this third letter maybe it is replaced by A, leading to the formation of UGA. Same, this U may be replaced by G. Here leads to the formation of U, G, G. So, when third letter is replaced by any one of these nitrogen bases, it leads to the formation of total 3 codons. For example, when it is replaced by C, U, G, C, it recognizes cysteine, the same amino acid. This codon is also recognized the same amino acid. When this U is replaced by A, it leads to the formation of UGA. This is a stop codon. Polypeptide chain will be stopped because of this change. And when U is replaced by the G, it leads to the formation of another codon UGG. It recognizes tryptophan. In this way, due to a change in single base pair of DNA, it leads to the formation of different codons. Sometimes these different codons may be recognize the same codon, may be recognize some other, may be recognize the same amino acid, or may be recognize some other amino acids. So, amino acid sequence is also changed in polypeptide chain. Similarly, here, for example, when the middle letter, that is U, when the middle letter, when it is replaced by any one of these, for example, middle letter G is replaced by U, it leads to the formation of U. Now, this triple U codon, it recognizes phenylalanine. For example, when this G is replaced by C, that leads to the formation of UCU. Now this codon, it recognizes serine. At the same time, when this U is replaced by A, it leads to the formation of UAU. Now it recognizes tyrosine. Okay, tyrosine. In this way, when this middle letter is also replaced by when some other remaining nitrogen bases, it leads to the formation of total 3 codons. One is recognized phenylalanine, other one is recognized serine, and other one is recognized tyrosine. For example, this first letter U, it may be replaced by some other letters, resulting in the formation of another 3 codons, which recognize 3 different amino acids. For example, when this U, okay, this is U is replaced by one CGU and AGU and GGU. When this first letter is replaced by C, it leads to the formation of CGU. It recognizes amino acid arginine. Okay, when this first letter is replaced by A, leading to the formation of AGU, it recognizes serine. When this first letter U is replaced by G, leading to the formation of GGU, it recognizes glycine. In this way, okay, this is the explanation how the codons are changed due to a small change at the level of single base pair, leading to the formation of different codons. Now these different codons may be recognized the same amino acid or different amino acids. Sometimes they may be converted into stop codons, which is capable of termination of polypeptide chain. So in this way, single base pair may be changed, resulting in the formation of different codons. Now these codons, they may be recognized the same amino acid or different amino acids. At this situation, polypeptide chain amino acids sequence is also changed. Now coming to another point. Here consider the statement. Okay, consider a statement consisting of some words in which each word is made up of 3 letters, just like these codons. That is Ram has, okay, Ram has red cap. Ram has This is one statement with 4 words. Every word is represented by 3 letters, just like the codons of a word. Here, each word in this statement is equivalent to the codon. Codon is represented by 3 nitrogen bases. Here, each word is represented by 3 nitrogen bases. Each word is represented by 3 letters. So, Ram has red hair. Now, okay, when one letter, that is B, when B letter inserted between has and red. For example, one letter B is inserted between, if B is inserted between has and red, what happened here? Ram, okay, has. Now B is inserted between has and red, B. Now this B is associated with RE, leading to the formation of a new codon. And remaining DC, D is associated with CA, leading to the formation of DCA. And P, it is considered as incomplete codon. Incomplete codon. What happened when B letter is inserted here? What happened? One letter B is inserted between has and red. When one letter is inserted between has and red, that is B, the entire reading frame will be changed. Entire mean this reading frame, it is rearranged where the letter is inserted onwards. This reading frame is rearranged from where this new letter B is inserted onwards. But before the insertion of B, such codons, they do not rearrange. So, when B letter is inserted between has and red, and reading frame will be changed from where the letter is inserted onwards. For example, when two letters BI are inserted between the has and red, what happened? Here also the reading frame will be changed from where the 2 letters are inserted onwards. Like this, here Ram has, here 2 letters B and I, they are inserted. BI associated with R, leading to the formation of a new codon. And EDC, AP. Like this, here when 2 letters are inserted between the has and the red, here also the reading frame will be changed, will be rearranged from where the 2 letters are inserted onwards. Like this, Ram has BIR, EDC, AP. For example, when 3 letters are inserted at the same position, that is BIG, what happened? For example, 3 letters are inserted at the same position. What about the reading frame? Now, Ram has 3 letters BIG are inserted. Now, RED and CAP. When 3 letters are inserted in between the codons, reading frame will not change, will not rearrange, but one additional codon is inserted. Now this additional codon, it recognizes one amino acid. One additional amino acid is also inserted in a polypeptide chain. No change in reading frame. Okay. For example, when the letters they are deleted one by one, the letters in this red, when they are deleted one by one, what happened? For example, one by one they are deleted from the red. R is deleted. What happened? Here, Ram, okay, has. Here R is deleted. R is deleted. EDC. Okay, and AP. When R is deleted, here also reading frame it is rearranged where the letter is deleted onwards. Okay? Here also reading frame will rearrange where the letter is deleted onwards. For example, two letters R, E are deleted. What happened? For example, Ram has two letters R, E deleted. Remaining letters D, C, A and P. Okay? For example, three letters R, E, D. Three letters are deleted at the same time. Deleted at a time. What happened? Now three letters are deleted. R, Ram has, okay, cap. Ram has cap. Okay? Complete codon is deleted. So now coming to the conclusion of these expressions. Students, when one or two letters are inserted or deleted, reading frame will change from where these letters are inserted or where these letters are deleted onwards. When one or two letters are deleted, when one or two letters are inserted, automatically the reading frame will rearrange from where they are deleted or added onwards. But when three letters or multiples of three letters are deleted or added, there is no change in reading frame, but one or multiple of codons are inserted or deleted. At the same time, one or multiples of amino acids in polypeptide chain may be deleted, may be inserted. Very, very important. Such mutations are called frame shift mutations. Frame shift mutations. Okay, these are called frame shift mutations. What are frame shift mutations? When one or two letters are inserted or deleted, reading frame will change, will rearrange from where they are deleted or inserted onwards, not before the insertion and deletion. Or when three letters are multiple letters, when three letters are multiples of three letters are inserted or deleted, reading frame will not rearrange, but one or multiples of codons are inserted or deleted, and one or multiples of amino acids in polypeptide chain, they are inserted or deleted. Such mutations are called frame shift mutations. Okay, and this is also one of the good evidence for. This is one of the best evidence. Okay, this is also one of the best evidence. Frame shift mutations are also the best evidence that the code is triplet. Code is triplet. Code is triplet. Frame shift mutations are also one of the best evidence for code is triplet. These are called mutations. This is the relation between DNA and the genes.